guys, prove root p. Root q is irrational, where p, q are irrational primes. So how people normally think that, sir, I can prove this separately, this is irrational and this is irrational. And I can say that what? I can say that what?
Some of irrational numbers are irrational numbers.
But this is wrong. Can I get a yes or no? Can I get a yes or no? Irrational plus irrational is not necessary to be irrational. Can I get a yes or no? For example, root 2 plus, this is irrational number. Can you tell me minus root 2 is irrational number, rational number? Rational, right? This is also irrational, this is also irrational. But if you add them both, what is the answer? 0, which is rational. 0. Right? Which is rational. How come you are saying irrational plus irrational is always irrational? It's wrong. So 3 plus root 2, just now we proved that is irrational or rational?
Irrational. Irrational.
3 minus root 2 is irrational or rational?
No.
Irrational. No, this is irrational, this is rational. If you add them, rational. So irrational plus irrational, it is not a right approach. Is this clear? It is not a right approach. So assume root p plus root q is
rational.
So what is the root p plus root q will be? This time you have to change the letter. Can I get a yes or no? A by b, where a comma b are
co-prime.
Co-prime integers.
Co-prime integers. Sir, shall I put simply co-prime? Please, my dear, safer side, right? You are going to write the board exam, or you are missing something. Co-prime integers, right? P not equal to 0. Now I have to squaring both. Can you tell me a plus b the whole square is what? A square, b square.
B square plus 2 root p root q.
Which is nothing but what? A square by?
A square by b square.
So can you tell me what is root p into root q is equal to what? This will come with where? Where it will go? On the RHS. Minus p
minus q
and whole by?
Divided by 2.
Is this clear? Agree with me? Everyone?
Yes, sir.
Yes, sir. Yes, sir.
So guys, what you have noticed that RHS is a combination of integers. But LHS is a product of
irrational numbers.
Rational.
Now the question is whether product of irrational numbers are going to be irrational?
Not always, sir.
Not always.
Not always, yeah.
What is that? What condition I have to give? Right. Can I get a yes or no?
Yes, sir.
Now, product of two different prime numbers. If two different prime numbers are not there, then root 2 into root 2 both are prime numbers. The answer is what? 2. So this condition is missing actually. Right? So, product of two different primes always irrational. Because we can say what? The prime number inside the root. Can I get a something like root 2 into root 3? Can I get a son root 2 into root 5?
Yeah.
Can I get a son root 2 into root 7? What do you get? Root 14. Guys, what you are getting? 6.
So these all are irrational numbers.
These are all irrational. Correct? Very clear. Is there any possibility two different primes inside the root? If you multiply, will you get rational number? Means will it get perfect square? My dear. Product of two primes, any possibility will become a perfect square? Product of two prime numbers, two different prime numbers, product of two different prime numbers, will it give a perfect square? Any possibilities? Impossible. Can I get a sir? No.
Yes, sir.
My dear, prime number nalme pirikka mudiyadu. Can I get a sir? No. Prime number means what? You cannot split. And if you want to get a perfect square, the only possibility is what? Product of two equal primes. Can I get a sir? No. Product of two equal prime numbers will give a perfect square. But product of two different primes is always, it's never be a perfect square. So root of imperfect square always irrational. Can I get a sir? No. Root of imperfect square always irrational. Any doubt? Root of imperfect square. Always what? Always what? So this is rational. Reason a comma. You can say what? It's a combination of integers. You can say what? Combination of integers. P comma Q also integers. Can I get a sir? No. Yes or no?
Yes, sir.
So what is that? Now it's a contradiction. Can I get a sir? No. This is irrational and this is
Rational.
rational. So LHS not equal to
Not equal to
contradiction. Which this is due to what?
wrong assumption.
Therefore,